everyone, welcome to my YouTube channel AI Stories by Anjali. In today's video, we are going to discuss about the continuation topic of our last week, that is the part 3 about question and answer analysis with basic NLP tools. In our last week, we have seen how you can get the answers for your own dataset which you have prepared with the help of OpenAI's ChatGPT based API. So this week we are going to see the same with the help of Bert. So we will discuss about how you can get the answers for your dataset using the Bert LLM model. So let us dive deep into the video. Before going that, I would like to thank to all my subscribers who have subscribed to my YouTube channel and who have been supporting me, and also want to request to the new watchers to please like, share and subscribe to my YouTube channel AI Stories by Anjali, and also please tap the bell icon for latest notifications so that you can get all the updates and all the new things which have been posted in my channel. So let us dive deep into the video. So firstly, if you remember, for anything you have, in order to do any project or something, you have to get installed and also import the required libraries. So we are using the sentence transformer library, that is nothing but a package, and also we are using the cosine similarity. So these are the two packages that are required for doing this task. Okay, so for that you are writing these particular packages, and why you're using sentence transformer. So I have already told you about so many things about transformers and how it acts as a base model for your LLMs, right? So those who haven't watched the basic concepts, please go to the playlist and start watching from the beginning of the series. Okay. So these are the two packages that are essential for us for doing this task. So why we are using sentence transformer? So basically, Bert is nothing but a bidirectional encoded representation of transformers. So the principal underlying architecture will come from the transformers. So sentence transformers is basically helpful for writing the code which is related to Bert, and also for dealing with the methods which are needed for doing this task. Okay, so I will show you what are the required methods in this code. And the second thing is cosine similarity. So I have already told you what is cosine similarity. So basically, whenever you want to get the nearest solution, like for example, whenever you asked a question, whatever the required answers which are related to that question in your knowledge database will be extracted using cosine similarity, nothing but the text similarity. There are multiple distances that you can calculate for dealing with text similarity. They're like Manhattan distance, Euclidean distance, cosine similarity, etc. But however, cosine similarity is the most widely used technique because it can avoid the outliers. Okay, so I have already explained why it is like avoid outliers like that in our basic videos, so please go and watch that. Okay, once you're done with importing, you have to initialize your Bert model. So for that, you're writing this line. So Bert underscore model, which is a variable, is equal to Bert based uncased. So Bert based uncased is the name of the model. So how you have used the GPT 3.5 Turbo, GPT-4, Text DaVinci, etc. So similarly, in the Bert model, you are using Bert based uncased. Okay. And then Bert underscore model is equal to, with the help of sentence transformer, you are getting your variable Bert model and passing it as an input. So how you are using client OpenAI's method by for initiating your client connection. Similarly, with the help of sentence transformer, you are passing your Bert model for getting initialized and running your model. Okay, so this is the main thing why you are using this sentence transformer. Okay, Remember, for writing ChatGPT, you want OpenAI package. For writing Bert, you want sentence transformer. In getting access, like whenever you are making calls with the help of OpenAI API, the first thing you have to use is initialize the client. For that, you are using OpenAI off and the API. Okay. And here for the Bert model, you are using sentence transformer off and the Bert model. So sentence transformer for Bert model, which is a package, and OpenAI, which is a package for ChatGPT. Okay, remember like this. So Bert model is equal to sentence transformer of Bert model. Once you're done with that, see the model has been gets initialized and it is been running. Okay. And then similarly, if you remember in the last week, I have shown you how you can write a simple function and how you can call for that. Similarly, we are writing the similar type of function here. Okay. So def, which is a Python function, keyword, and calculate cosine similarity and the question as well as answer. So question underscore embedding is equal to Bert underscore model dot encode of question. So Bert underscore model is the variable which you have initialized here for your Bert model, and then encode of question. So basically, if you observe, I have already explained you in our conceptual video what is encoder, what is decoder, how Bert will work, and what is the simple transformer architecture. So in the same thing, this encoder and decoder concept will work. So basically, encode means you are converting text to numbers. Decode means again you are converting back numbers to the text. Okay. So this is the underlying principle. Remember. Okay. So question answer underscore embedding equal to Bert underscore mode of encode of answer. So once if you encode your answer, that will nothing but an answer embedding. Okay. And then cosine similarity value equal to, and then you are applying the similarity distance for your embeddings. So I have already told you. So whenever you are storing your knowledge base into the vector database, nothing but your vector database. Okay. So it is nothing but you're storing in the form of numbers, because a model cannot understand the text. Okay. So in order to make the model to understand, you're converting your text into the numbers, and for that you're using embedding techniques. Okay. So that's why, and for the similarity, you'll calculate the cosine similarity for your embeddings. Okay. And then you will decode it. So once you decode, you will get again the text back from your numbers. So this is how the principle works. So if you have any doubts, please go and watch the video which I have kept earlier in our conceptual videos in the generative AI and LLM series, so that you will get a clear clarity of what is encoding, what is decoding, what is embedding, what is LLM. Okay. Remember, this is a very simple topic. So don't think that it's like a complex. So whenever you are dealing with LLMs, especially the Bert, you have to know transformer, what is encoder, what is decoder, what are embeddings. Okay. Okay, then once you apply your cosine similarity to your embeddings, you're just returning those cosine similarity values. That means you're returning those answers. Okay, so that is about the function. Now, you have to enumerate your loop and you have to see how it is generating. Okay, so for that you are using this thing. Okay, for I comma pair in enumerate for paid underscore data set of all is to this. So basically you are just checking for three things. Okay, so for F question, pair of question, and correct answer is pair of answer. Okay, and then correct answer is cosine similarity of calculate the cosine similarity with the question and the answer. So and then again you're calling the GPT model's answers also. Okay, so that's why you're just asking OpenAI of GPT model, and answer is OpenAI answers, and for correct answer OpenAI GPT model answers cosine similarity, and then you're just passing your cosine similarity variable like the function thing, that is nothing but this one, and then you're just extracting the answer. Okay, so basically you're doing one thing, you're just printing the question, you're printing the answer, and then you're printing the correct answer and the OpenAI model's answer, just to tell like how the OpenAI is working too. Okay, so see if your answer is output, like your output question, George wants to warm his hands quickly by rubbing them. Which skin surface will produce the most heat? So the correct answer is dry palms, and the correct answer is question cosine similarity 0.4. So basically for this thing, the cosine similarity answer is this. Okay, so since you're getting this answer, how you're getting this answer, this will be getting by using the text similarity. How that is performed? With the help of cosine similarity. Okay, of course there are multiple distances, but you're using the cosine similarity, and then you're using the OpenAI GPT model answer, that is PANS, and then the correct answer is cosine similarity of this. So basically this is your Bert cosine similarity distance, and this is your OpenAI's similarity distance. You're just seeing the distances. Okay, so in this way you are getting the answer. So this is the underlying process that is working in order to get you the answer. Okay, so because many times you're wondering how, whenever you ask a question, particular question, how GPT is giving you the responses correctly. So that is basically the similarity, that is nothing but text similarity. Okay, so next, if you see this, which of the following statement best explains why magnets usually stick to a refrigerator door? And the correct answer is the refrigerator door contains iron. And then if you want to extract the cosine similarity, which is nothing but this one which you calculated for your answer, so this will be the cosine similarity distance, and then you're just seeing the OpenAI's answer, and then its similarity, it's 0.5587. Similarly for this, so basically you have taken only three questions. Okay, see, all and 0 is to 3, that is nothing but 0 1 2, so total 3. So for 3 questions you're doing this. Okay, so that's why you have been getting this 1 2 3. Okay, 3 outputs. Okay, if you want for entire thing, you can just if you like, if you have a empty thing, then it will take all. Suppose if you want the last one, then you can keep here -1. So you know, right, that is list indexing. So how many questions you want, then for that particular thing which you prepared in your data set, that many answers will be get extracted. So in this way you can use a Bert for getting answers for your questions. Okay, so this is the basic question and answer analysis with NLP tools. So basically you have prepared a data set, you have extracted using the OpenAI's GPA and also with the Bert. So in this way you can use this LLM models for preparing a simple question paper. I hope you understand this video, and those who ever have doubts regarding this, so please comment in the comment section. I'm happy to reply, and also we'll discuss more about doubts thing too in the other videos. So, and those who wants any new topic or any suggestions, or who want something like to know about like some knowledge or something, what kind of videos that you're expecting from me, you can just comment me in the comment section, so that I'm happy to prepare the videos regarding those. Thank you so much for watching this video. Thank you.